Hey everyone, in the last video we learned about Closure and its first application, memoization. Okay, and in this video we will learn about its second application, currying. So before starting currying, let's revise it once. What is Closure? So Closure happens when a function retains the references of the variable of its enclosing or outer function, even when the outer function is done execution. Okay, so this is Closure. So simply closure is functions of a function bundled together with its lexical or surrounding state. Okay. So this is closure. Now let's start currying. So what is currying? So currying is a technique in functional programming which allows us to break down a function with multiple arguments into a series of functions with a single argument. Okay. Let's take example to understand it properly. Fine. So suppose that we have a function add which takes two arguments a and b and returns the sum of it. Okay. So if we want to convert this into a curry function, then what will happen, like suppose that the name of the curry function is curry add. Okay. So what will this function do? If we want to call this add function, then how we call it? We'll call it like add 1 and 2. Okay. So after we convert it into a curry function, then this curry add function will take one argument and again take second argument. Okay, this technique, converting this add function to a function like this, is known as currying. Okay, so now let's see how can we do it. So we can use closure here. Okay, so let's start. So let's define a function curry add. Okay, and in closure we know that the inner function, this inner function will remember the variables which are defined outside of it. Okay, so in the curry add function we will take only one argument a. Okay, and here in the inner function we will take the another argument b. Fine. And as it is a closure, so this inner function can access this a. Okay, so then we can return a plus b. Okay, so this is how we can convert this add function to this curry add function. Okay, now let's run it. Okay, so suppose we calculate the function, store the value of this function, whatever is returned from this function, in a variable name sum. Okay, so this curry add, no, not sum, let's name it add a. Okay, so this curry add will take a single argument 1. Okay, and what will this curry add return? It will return another function. Fine, that inner function, and that function, whatever it returned from here, is stored in this add a variable. Fine, and if we want to run this inner function, then we have to call this function again add a, and here we can give this argument 2. And so now you can see that, and let's store this in variable answer. So this whatever returned from this add a function, this a plus b, is stored in a variable called answer. Okay, now we can console it, console.log answer. Okay, now let's test it. The node curry. Okay, so here you can see 1 plus 2, 3 is returned. Now let's test it for one more argument, 4 and 5. So it should return 9. Fine. So you can see our function is working. So instead of breaking down this curry add function in 2 steps, like here first this inner function returned, now again calling the inner function with the different argument, we can simply call it here only. Fine, like here this will return a function, and here only we will call the return function. Okay, so 5. Okay, so this can be broken down into single step, and we can store it in variable answer, so you can see it will give the same result. Okay, so that's how we converted a add function which takes two argument a and b into a curry add function, which is a series of functions which and each function takes a single argument. Okay, this 4 and then 5. So this is how currying is done in JavaScript. Okay, now let's take one more example. Okay, so suppose we have to make a function sum which takes a series of arguments like this, 1 then 2 then 3 dot dot dot, like whatever till how much we want. Okay, and that function returns the sum of all the arguments. Okay, so suppose that 1 2 3 till 10 is there, so it will return the sum till 1 to 10. Okay, so we have to implement this function. Fine. So how can we do it? Like after seeing this function, we can directly say that this is a currying problem. Okay, so we can solve it using currying. Okay, so let's start. Let's define the function sum. Okay, and it takes a argument x. Okay, and inside of it will return another function. Okay, and this will take argument y. Fine. And now we have to return the sum of x plus y. But here we can have multiple arguments. Like it will not stop till y only. Okay, like after this x plus y is done here, it can have more arguments. Okay, so at this step we need to check one more function call or not. Okay, so if there is one more function call, then we have to call our this function recursively so that it can call up the functions after that. Okay, so here we will check that if this argument, like after this by this argument here, it exists or not. Okay, so if this by exists, like we have more arguments after that, then we can call our function recursively this x plus y. Okay, and if it is not, then we will simply return the value whatever has been calculated till this function. Okay, x. So that's all. This is the implementation. Now let's test it. So let's call the same, store it in a variable answer 2. Okay, and here let's suppose that we have to call sum till 5. Fine, so this will return the value of 1 plus 2 plus 3 plus 4 plus 5, which is equals to 15. Okay, so it will return 15. Let's run it and let's comment it for now. So you can see 15 is coming here. Fine, so if you want to test what is the value of this x and y at each step, then we can add console log here. Okay, so suppose we are consoling x and y here. Okay, so now if we run it, so you can see at the first step, like for this 1 and this 2, we are getting x and y as x as 1, this x is coming as 1. Okay, and this y is coming as 2. Fine, and now after at this step we check if we have more by or not. Like this is done. Okay, so this has been done, so we will check if the y is there, y was there or not, and y was there, like we have 2 here at y, so it will call our function recursively, and here we will pass x plus y. So what is x plus y? 3. So this sum 3 is returned from here. Okay, so at this step this x become 3, and then the y become this 3. Okay, so here you can see this x and y is coming 3 and 3. Okay, and here also it checks if this by exists or not. So we have by, like this 3 was there. Okay, so this by still exists, so again this by exists, so this will our function will call the sum function again recursively. Okay, at this step this x plus y, 3 plus 3 will is 6, so this 6 is get called, and here this becomes 6, and after that the y, this x becomes 6 and the y becomes 4. Okay, so again 6 4 x y is locked. Okay, so this happens till we have by, like at last step this argument is empty. Okay, so at this step this is the base case of our recursion. So at this step we will simply return x, like whatever is calculated before that. Okay, so that's how we can implement this function. Okay, so that's all in this video. Thank you for watching.